Welcome to the second episode of how to use the power rule to differentiate functions. In this video, you are going to learn how to use the power rule to differentiate or find the derivative of fractional functions. So if you haven't watched the first episode, just click on the link that is showing on the top right corner right now. The first example says find the derivative of y is equal to 1 over x. By the laws of indices, if you have a number a that has been raised to a negative power, to make this power positive, this is going to be written as 1 over the base a raised to the power positive 1. So any number raised to the power 1 is the number itself. So we're going to write 1 over the base a. So in our case, the base is x. So we can rewrite this function as y is equal to x to the power negative 1. All right, here x has a coefficient of 1. So this is same as 1x to the power negative 1. I've written the 1 like this, the coefficient 1 like this, so that it's easier for us to differentiate. All right, so we are going to say dy over dx, meaning we are differentiating the function y with respect to x is equal to this power will multiply by the coefficient of x. So we have negative 1, all right, negative 1 times 1 times x to the power negative 1. Now from the power, we subtract a 1. So we'll have negative 1 times 1 will be negative 1. Negative 1 times x will have negative x to the power negative 1 minus 1 is negative 2. So taking this back to a fraction, we're going to have negative 1 over x squared. So we can conclude and say, therefore dy dx is equal to negative 1 over x squared. So this is the derivative of the function y is equal to 1 over x. If you're with me up to this point, it means you're enjoying what I'm doing. Why can't you subscribe, hit the like button, comment, and share? All right, here is the next example. Feel free to pause the video, work it out, and then compare your answers with the answers that we're going to find together. So this function y can be rewritten as y is equal to 10 times 1 over x, so that we have 1 over x, which was in the previous example. All right, so we can have y is equal to 10 times x. This can be written as to the power negative 1 from the previous example. So we have dy over dx is equal to this power will multiply by the coefficient of x. So we have negative 1 times 10, all right? Negative 1 times 10 x to the power negative 1, right? Minus 1, all right? From the power, we subtract a 1. So we have negative 1 times 10 is negative 10. Then x to the power negative 1 minus 1 is negative 2. So taking the x to the power negative 1 back to a fraction, we are going to have negative 10 times this from the previous example is same as 1 over x squared. All right. We now conclude and say dy over dx is equal to negative 10 times 1 is negative 10 over x squared. So this is the derivative of the function. All right, here's the next example. Feel free to pause the video, work it out, and then compare your answers with the answers that we're going to find together. So this function can be written as y is equal to 7x to the power 1 minus, and then this can be written as 4 times 1 over x. All right, so this is the previous situation. Also here, we're going to have plus 3 times 1 over x cubed. All right, so we can write this as y is equal to 7x to the power 1 minus 4. Then this can be written as x to the power negative 1 plus 3 times, and then also this can be written as x to the power negative 3 from the laws of indices. So we can now go ahead and differentiate or find the derivative. So we're going to have dy over dx is equal to, this power is going to multiply by the coefficient of x, this power is going to multiply by the coefficient of x, this power is going to multiply by the coefficient of x. So we'll have 1 times 7, all right, 1 times 7, then x to the power 1 minus 1, then negative 1 times negative 4, all right, so we'll have negative 1 times this negative 4, then x to the power negative 1 minus 1. Then this power is going to multiply by positive 3. So we'll have minus 3 times positive 3 times x to the power negative 3 minus 1. So we'll have 1 times 7 is 7, then x, then 1 minus 1 is 0, so the power is 0. Then negative 1 times negative 4 is positive 4, then x to the power negative 1 minus 1 is minus 2. Then here we have minus 3 times positive 3, we have minus 9. Then x to the power negative 3 minus 1 is minus 4. So we are going to have 7 times x to the power 0. Any number to the power 0 is 1 by the laws of indices. So 7 times 1 will have 7. So here, this will reduce to 7 plus 4x to the negative 2 minus 9x to the negative 4. Now taking this back to a fraction, all right, the x is back to the fraction, we're going to have 7 plus 4, 1 over x squared. We've just changed the negative power to positive by the laws of indices, remember in our first video, then minus 4th power. So we can conclude and say, therefore, dy over dx is equal to 7 plus 4 times 1 is 4 over x to the 2nd power minus 9 times 1 is 9 over x to the 4th power. So this is the derivative. Again, if you are with me up to this point, it means you are enjoying what I'm doing. Why can't you subscribe, hit the like button, comment, and share? Here's the next example. Please feel free to pause the video, work it out, compare your answers with the answer that we are going to find together. So this function can be written as y is equal to 3x squared plus 7 over 3. Then here we have 1 over x, all right? Again, here is same as minus 6 times 1 over x to the 4th power. So this can be written as y is equal to 3x squared plus 7 over 3 times, so this can be written as x to the negative 1 minus 6 times x to the negative 4th power. All right? So now we can go ahead and differentiate this or find the derivative of this. So we have dy over dx is equal to, this power will multiply by the coefficient of x, this power will multiply by the coefficient of x, and also this power will multiply by the coefficient of x. So we have 2 times 3, all right? 2 times 3, x to the power 2 minus 1, then negative 1 times 7 over 3, so we have negative 1 times 7 over 3, then x to the power negative 1 minus 1. Then this power is going to multiply by this coefficient of x, so we have minus 4 times minus 6, all right? Then x to the power negative 4 minus 1. So we have 2 times 3 is 6, x to the power 2 minus 1 is 1. Then negative 1 times 7 over 3 is negative 7 over 3 x. Then negative 1 minus 1 is minus 2. Then negative 4 times negative 6 is positive 24. Then x to the power negative 4 minus 1 is negative 5. So taking back the x's to fraction, we are going to have 6x. All right, this is going to be as it is because x to the power 1 or any number to the power 1 is the number itself. So we have minus 7 over 3 times this is same as 1 over x squared plus 24 times this is same as 1 over x to the 5th power. All right, so we have 6x minus 7 times 1 is 7 over 3x squared. All right, this. Then plus 24 over x to the 5th power. So therefore, dy over dx is equal to 6x minus 7 over 3x squared plus 24 over x to the 5th power. All right, here's the next example. Feel free to pause the video, work it out, and then compare your answer with the answer that we're going to find together. So this can be written as y is equal to 3x squared plus 7 over 3 times 1 over x minus 6 over 11 times 1 over x to the 4th power. So we're going to have y is equal to 3x squared plus 7 over 3 times x to the negative 1 here, all right? Then minus 6 over 11 times x to the 4th power. All right, negative 4th power. So we can now differentiate, or we can now find the derivative. So we're going to have dy over dx is equal to this power is going to multiply by this coefficient, this power multiplied by the coefficient, even this power multiplied by the coefficient. So we have 2 times 3 x to the power 2 minus 1, then negative 1 times 7 over 3, so we have minus 1 times 7 over 3, then x to the power negative 1 minus 1, then this negative 4 will multiply by this, so we have negative 4 times negative 6 over 11 times x to the negative 4 minus 1. So here we have 2 times 3, which is 6x to the power 1. The negative 1 times 7 over 3 is negative 7 over 3 times x to the power negative 2. Then negative 4 times negative 6 is positive 24 over 11, then times x to the negative 5th power, because negative 4 minus 1 is negative 5. All right, so taking the negative powers to fraction, we are going to have 6x, because here x has been raised to 1. Any number raised to the 1 is the number itself. So we have minus 7 over 3 times 1 over x squared, all right, here. Then plus 24 over 11 times 1 over x to the 5th power. So here we can conclude and say dy dx, all right, therefore dy dx or dy over dx is equal to 6x minus 7 times 1 is 7 over 3 times x is 3x squared. 3 times x squared, all right? So this, all right? So we have this. Then positive 24 times 1 is positive 24 over 11 times x to the 5th power is 11x to the 5th power. So this is the derivative. Thank you very much for watching. Once again, if you are new to this channel, please consider to subscribe, hit the like button, comment, and share. See you in the next video where we're going to be looking at differentiating functions involving surds using the power rule.